Right, my name is Martin Woodward, martinwoo@microsoft.com if you want to email me, @martinwoodward if you want to send me some abuse on Twitter or if you want to get me on GitHub or whatever. Visualstudio.com DevOps is where I hang out. I'm fancy title Principal Group Program Manager DevOps. What does that mean? Principal Group Program Manager means I delete a lot of email. DevOps means I delete a lot of email with a bash script, basically. So. Yeah. I work on a thing called Visual Studio Team Services, which is our collaboration system. So for engineers, so it's Git hosting, agile planning, Kanban boards, work item tracking, all your release management, all your builds. You can do hosted and on-prem builds and all that sort of stuff. And there's all telemetry and all that thing via the cloud, because we all we love the cloud. And yeah, that's about as much of an advert as you're going to get from me today, because I'm on the engineering side, but that's what I work on. When I joined Microsoft in 2009, a cartoon came out the year after of like the top tech companies and their org charts. And coming into Microsoft from a cheeky little startup, this felt very familiar to what I was witnessing when I came in. It was a very hierarchical organization, and not everybody talked to each other. One of the things that Satya Nadella did when he came into the org was break a lot of these boundaries down inside Microsoft and really try and get everybody to work as one Microsoft. And that means one engineering system in Microsoft as well. If I want to go into Notepad and add Unix line ending support into Notepad, and believe me, I've tried, okay? And so I was finally trying to do that. I can actually now go look at the Windows source code and find it, because it's in VSTS, it's in the same hosting systems we sell to everybody else, it's in those. And I can send them a pull request, and they can reject it. Believe me, they will. But we use these inner source style workflows inside the company because we're all in one engineering system, which is hosted on top of Visual Studio Team Services. So we now have in that engineering system, as I say, 75,713. Sorry, there we go. That was the number at the end of August, so it keeps going up and up. That's everybody in engineering. That's like Windows, Office, Azure. So we have this amazing thing where the engineering tools are deployed to Azure using the engineering tools, because remember we have a build and release management system. The Azure is deployed to Azure using the engineering tools hosted on Azure. Azure hosts, runs a lot of Windows, which is built using the engineering tools which are hosted on Azure, and it's like Inception. So I think there's like a backup plan. I hope there's a backup plan if it goes wrong. Probably involves like computers buried in mountains or something, but I'm not going to worry about that. I'll get fired if it happens, so I'll be fine. The journey to DevOps has been an interesting one for us. When I joined in 2009, we were shipping shrink-wrap products, yeah? My first course I had to do when I joined the company was to approve the hologram that was used on the DVD that my product was now shipping on. I came from a startup, and I'm in a course about approving holograms to go on DVDs that get made in Dublin and in Puerto Rico. I was like, what am I doing? This is gonna be weird. But the whole company has moved closer to how I was working anyway, in my little cheeky startup. So it's been a really great transition to be part of. We started the journey in probably around 2010 from shrink wrap to service, and we're now a fully online service. There's a couple of regular trains that ship every day, but we can patch production all the time. And then there's a big train that happens every 3 weeks as well, because we have like a 3-week sprint cadence as well for the big feature crews. So it's a big transition. Great fun to be part of. The 5 things, I tried to break this down into kind of 5 things we kind of learned as we went along to try and make it more applicable to everybody else. So the first one was to be completely like customer obsessed, customer focused. And this is easy to say, but I'll try and explain what I mean in practice. Obviously we do all the, like the usual stuff you're trying to do when you're listening to customers. You have a user voice, yeah, check, we've got one of those. You have Stack Overflow tags, check, we sponsor ours because we're Microsoft, so might as well give the Stack Overflow guys a bunch of money because they're awesome. And then we also do some things a bit more in depth where we we have direct relationships with a lot of our customers, into the engineering team. So we have our top customer accounts, customers who are top, not just in terms of usage, but in terms of they're doing interesting stuff that's maybe a bit different. We assign them a champ, who is a person who is on one of the engineering teams inside the product, and they go talk to them, and they completely shortcut all the product support. They shortcut, the salespeople, because who wants to talk to them? It's just engineer to engineer, just helping the customer be more successful. And we also obviously have in-product feedback and all that sort of stuff, which you probably all do, and collect a stack of telemetry. Our definition of DevOps inside the company is this union of people, process, and tools. So it's about delivering value as quickly as we can to our customers. All of the things we build with the mindset of how do we get this into the customer's hands as quickly as possible. This is how we define when a feature is done. So in the old days when I first started, it was done when it was checked in, And then you would go through these massive stabilization phases and you would fix bugs and all sorts of badness would happen. Then it became, when we did Agile, it became done was potentially shippable. And then that's kind of got a bit of a woolliness to it, what's potentially shippable, what's not. Nowadays, done is shipped. So everything at the end of sprint has to be running in production. It has to be collecting telemetry, and that telemetry has to tell you if the hypothesis, the experiment you're running, is true or false. How are you proving or disproving your hypothesis? And your hypotheses are always in terms of customer value. I think that if we change the system in X way, people will be able to use this faster, or people will be able to do that better, or we'll get more revenue, or we'll reduce the cost of running the system, those sorts of things. We collect tons of telemetry. What does that say? So it's just knocking on 2 petabytes of telemetry a day come into our system, which we ingest using, we call it Custo, but I guess Azure Application Insights Analytics is our catchy name, because Microsoft's awesome at naming things. But Custo is what we all call it internally. And it's an awesome way of, we basically bring in a ton of data. We capture as much data as we can, obviously without the PII parts. We ingest a bunch of data. And then that allows us to ask questions after the fact. But we try and measure only what we want to care about. We're very careful about what we measure. So here's an example of some of our dashboards. We measure things like, are you using your features? How quickly can I build something? How quickly can I get to self-test? What's my time to deploy? These are very, very important ones. How quickly do we detect lifecycle issues? How quickly do we tell people about them? How quickly do we fix them? And then how quickly do we remediate them? How quickly do we stop them from ever happening again? These are things we don't watch, which I always like to highlight. We don't ask people how long it's going to, how close they were to their original estimate. We don't ask them what their team's velocity is. Because as a manager, I don't care. I just care what your results are, what you're delivering to your customers. I don't care how you got there. I honestly don't care. And I want the team to be self-empowered to do whatever it is they want to do to get that way. But if you're not delivering value to your customers, then I care. We also have some debt counts and things like that to make sure we don't build up too much debt. But yeah, that's that. When we're looking at customers, again, one of the things we like to do is focus on the outliers. When you've got a big service, we've got millions and millions of customers now, which is awesome, and it's great. It's actually reasonably easy to stay up most of the time when you're in multiple data centers to millions of customers. So those 9s start not to mean as much in your SLAs. So what we do instead is focus on the experience each customer is having, and I mean that by a customer account. So if you are a user of VSTS, what's your experience? And then we look at the outliers. And I had some story I was going to tell here, but then a better one happened at the weekend where a customer we noticed was looked weird, and our telemetry was picking up, this is odd. The machine learning models were, hey, this is weird, something's going funny here, what's happening? A bunch of data was getting deleted by a job that was running with admin privileges at the API level with warnings switched off, and we're like, huh. So we ring up the customer, and it turns out the admin for that customer was doing a migration job with warnings switched off that they'd written wrong and was deleting most of the data in their account. And so we were like, hey, you probably don't want to do that. And so we ended up starting doing a backup for them, a restore, and got them back up and running on Monday morning. So we still have a VSTS administrator in that organization that's not been fired, so that's good. Our customer champ knows who to talk to. I can't promise that level of service, but that was an example of things that can happen when you're looking at the outliers and trying to identify strange patterns. We do subscribe to build, measure, learn, so hypothesis-driven development, rather than, so our user stories tend to be around the, we believe this wants this, and we're going to test it to see if they do. How are we going to write the tests, those sorts of things. We do that, we are always deploying into production, and we do this by using feature flags. You heard everybody sort of, no, okay, so a feature flag is basically, it's a fancy name for an if statement, okay, in your code. And so rather than having big, long-running feature branches, which you then merge when you're really sure it's ready, we're trying to always ship from master and always be continuously integrating as much as possible. So once the code, with fairly high degree of confidence the code's good, we integrate it in very, very early, but we have it switched off. So we'll put an if statement in, we'll start implementing the feature, and then we'll make it toggleable so you can switch that feature on or off. And then we do things like we measure, for people that have opted into the feature, we measure how quickly they if they opt out, how many people opt out, because opt out is a sign that the feature's not good. And it's like, it's a classic, UX is a bit like a joke. If you have to explain it, it's not working. And the same's true, that's how we measure things. We measure if UX or UI changes or product changes are working by if users, when they switch to it, if they stay with it. If they don't, and it's not working, I don't care how fancy you're telling me it works. It doesn't. People are opting out. So we do everything based on data. Sorry, I've been hanging out with Americans too much. And they're awesome, and they're great. The problem with feature flags is it enables dark launch. So you can build a feature, you can have it running in production, and then you can have some fancy event where you get like some executive to stand up on stage, press a big red button and say, ta-da, the feature's now live, which is awesome, until it goes wrong, okay? So we did one the other, a while ago, a few years ago. We switched it on stage, got the exec to switch it on stage, and then his demo bombed because the whole site started going down. Now, we'd rehearsed that loads and loads and loads with the feature flag just switched on for that particular demoer. It worked great. But once we switched it on, turns out everybody started using it, and there was some problem with the live load coming in, and it impacted us, and it was a nightmare, and we had a bunch of egg on the face, so don't do that, okay? We switch our feature flags on gradually, and we do it well before a big event, just to make sure everything's running, the system's in steady state. That takes me on to having a production-first mindset. So our live site instance, we have live site instance, basically a fancy name for a conference bridge. When there's a problem's detected, a conference bridge gets fired up. Nowadays, it gets fired up using like AI, because we're Microsoft, you try and throw in some machine learning in there. So it fires in machine learning, and it calls a conference bridge and gets what's called the DRI, the directly responsible individual, on the phone and pages them. When you are in your team, you have 5 minutes during the working day to get on the phone bridge, or 15 minutes in the middle of the night, or if you're walking around Harry Potter world like I was the other week with my family, but never mind. That's the joys of being on call, as we all know. DevOps teams is awesome. So we want to try and minimize those, which is why we then go into self-healing and things like that to try and minimize the number of alerts. When we do go wrong, we try and be incredibly transparent about it and give a lot of detail to prove we're not idiots. But the key is that our alerting systems needed to get really good, and that we were able to detect quicker. And this is why time to detection is an important metric for us. When we have a live site incident, we want to make sure we put systems in place so we can detect that problem again quicker if we can't completely stop it from ever happening. One of the things we also learnt is an important lesson is no such thing as partial automation. I'm about to show you some PowerShell, okay? In the old days, we used to copy scripts around and things like that. We used to have a script that was built up that you ran when you did the deployment. Anybody see what the problem is with this script here? It's PowerShell, but apart from that, what's the problem? Okay. Smart quotes. When you copy things around in emails, it turns like proper quotes into these crazy smart quotes and breaks everything. That happened and we broke production one day. Awesome. So, no such thing as partial automation. Automate everything. Nowadays, we can't run scripts in production. You have to check them in and then run them from what's in version control. Again, it's just little things like that you learn. Mistakes, but never mind. And when we go through production, we go through 5 rings. We're the first ring. And then we go to our smallest data center, we go to our biggest data center, we go to our furthest away data center, and then we do everybody else. And that's kind of how we roll stuff out. And that helps us detect early if things are going to go wrong, and then it gives us a high degree of confidence before we deploy to the rest. So we do stage deployments. When we are doing this as well, it's important, like instilling this live site culture was the biggest change when we went from product to service. We also think a lot about security. Whenever I get an email that has a link in it, nowadays, I'm assuming it's my own security team trying to phish me to get into the system. It's like no holes barred. We have our own internal pen testing teams that try and break us. But more importantly, we also have our own internal teams that are trying to spot the pen testers. So you assume a breach mentality, and you do wargaming to try and make sure you can detect who's in and who's not. And I'm quickly going to whip through this because we already talked a bit about this in the keynote this morning. We also are a big believer in team autonomy. So that book I mentioned, a cheats way is go look up RSA Animate on YouTube and watch the video. It takes 5 minutes, saves you reading the book. But we have autonomy at the plan and the practices, but we have some alignment within the business about how we operate. Sorry, I'll pull that one back up. Slides will be up on SlideShare afterwards, don't worry about it. So the reason why you need some alignment is if you give 2 people too much autonomy, bad things can happen. Here's a case when we brought Windows over. We brought them in. We had a migration plan. We were going to do it a bunch of ways. Then Satya came on board, said, no, they're going to go use VSTS, and we want them there in 2 weeks. I went, oh, OK, awesome, 2 weeks. When you get a deadline like that from an executive, you take a lot of shortcuts. So we said yes to a bunch of stuff, which we later regretted. We looked at their bug form when we did this. This is how many fields they had in their bug form because we kept saying yes to them. Hang on a minute, sorry, let me scroll down. This is how many fields they had in their bug form. It was nuts. So then we had to do a process where we simplified that. Here's how we have our team structured. We bring engineering and test got brought together into an engineering team. And then we have a single feature team that's got program managers, people like me, engineers and ops people all in one team, all delivering the value to the customers. They all live in one team room. They all have a clear charter. They stay together. We might change their team's charter, but we keep the team together for 18 months. And that's very important for team dynamics and things. We do allow teams to move around, though. We allow mobility. Sorry. We keep the teams. It's a vertical slice, so it's not like a back-end team and a front-end team. It's you own the entire customer feature. Every 18 months, we do this thing where we allow engineers to self-select where they go work. So as a manager, I pitch my team what we're going to work on, what my vision is, and then engineers come along and decide if they want to work for me or not. Incredibly scary. As a good manager, you kind of pitch and make sure you're going to get your right team in place. But it allows mobility within our org without people deciding the only way to have career prospects is to leave. So we try and encourage mobility within the teams, and then we lock the teams down for a year or so, 2 years, and then keep them together. When we plan, we have these 18 months big goals. They're just like literally bullet points. The 6-month plan is the point of like where we have screenshots, wireframes kind of thing. 3 sprints is the only way we can actually sensibly plan something. It's the only thing we actually believe in. And then a sprint is the only thing, like, I know what's going to happen this sprint. I mean, we're in sprint 125 right now. I have a good idea what's going to happen. I kind of know what's going to happen in sprint 127. And my 6-month plan is just some wireframes that I'm kind of going, we're going to go do this kind of, boss. Is that all right? And that's how we do our planning. So leadership look at the season plan, and then the feature teams have complete control over how they deliver everything else. Complete autonomy. Doing this, it's awesome, and everybody smiles and puts post-it notes on whiteboard. I think that's what that slide says. Okay. Then next one is around shifting left. So we had a lot of tests that were UI tests, and we needed to move that to proper integration tests that we could run everywhere. And it's great to say, and everybody says that in manuals. I just wanted to make you feel better by how long it took us to do that, okay? Because we had a big legacy code base. It took us years, literally. You can see from sprint 78 to sprint 120. So it's taken us, times that by 3 weeks, a long time. But we got there. So it can be done. Have faith. Gently chip away at it. We also do a lot of stuff in our pull requests. So this is what a pull request looks like in VSTS. We do a lot of pre-merge validation. So we do a bunch of security testing and a bunch of build validation before we merge because we want to continuously integrate. And then the final thing, sorry I've been rushing through this, but I want to get it. The final thing that we learned was trying to learn how to treat infrastructure as a flexible resource. We went from a big monolithic application that was shrink-wrapped to running in the cloud, and we want to try and have the benefits of the cloud. So we started by making use of the dev test environment because it's easy to do dev test even if you're still shipping on-prem. So we went from VMs under a desk to VMs in a lab to using Azure Dev Test Labs, which allows us to easily fire up dev test VMs in Azure, which are still connected to our corporate network. And then that's awesome. And even though we're not shipping out there, we're still doing this sort of thing. So, awesome using the cloud. We ship the same code on-prem as we do to the cloud, which is important. This is how we structure our data centers. We had one code base, which we've now split into 2 services. And then, that was painful, okay? Because it was a big monolithic code base. That gave us the ability to scale across data centers, which was key. And then once we had that capability, we did that. Now we're taking this code base and actually containerizing a bunch of stuff. But again, it's not easy, okay? You can't just containerize overnight. So we're taking individual new services are being built as containers, and we're Dockerizing those and running them as microservices. But we've still got this big monolithic code base that we're gradually pulling things out of, And to be honest, that's how most normal business applications end up happening. It's not, you can't just rewrite everything. And then finally, what did I want to say here? Oh yeah, containers are awesome because it allows us to do better cost analysis, basically. So you all know why containers are awesome, so that's cool. Right, okay. Last thing, DevOps isn't this magic unicorns and rainbows, despite what everybody thinks. It's hard work. The technology wasn't the hardest part. The hardest part was the people part, was building a live site culture within the team and actually transforming how we did our business. But we knew we needed to because we knew we needed to worry about how quickly we shipped, not the meantime. So the meantime to release, not the meantime between failures, was what we wanted to focus on. Because that allowed us to innovate quicker, allowed us to build quicker and test things with customers. And then we can take those same learnings, put them in the same shrink-wrap product, which we do, ship it quarterly, which we still do for people who don't want to be on the cloud. But we were able to transform our business to allow us to still be doing DevOps, still be agile, but also still keep our on-premise product as well. So that's kind of that, blah, 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 blah. We did a bunch of stuff. And then finally, if it hurts, just do it again, right? When you're automating, if it's painful, then do it again until you get good at it. If it's good for you, keep doing it until it stops hurting. And make it your engineer's responsibility, because then they'll automate it, especially if you call them up at 3 in the morning. And that'll do. Okay, I think that's about it. Thank you very much for your time. Any emails, just give me a shout. Thank you.